In this video, we are going to see dissociation constant of acid and base. So, first we will see what is the dissociation constant of acid and then we will go for dissociation constant of base. So, for acid, I'll go slowly and for base, it will be a revision. So, let us see what is the dissociation constant of acid. So, students, dissociation constant of acid is also called as acidity constant. So, and it is denoted by Ka. It is also called as acidity constant. Now, let us see what is this and what is the definition for this acidity constant. For that, I will start with an example. For this, we will always consider a weak electrolyte. Now, as I am considering the dissociation constant of acid, I will take a weak acid. So, consider a weak acid. Now here I am taking a weak acid as Ha and I will dissolve that in water. Now when I dissolve that in water, being a weak electrolyte, how it will dissociate? It will give me H plus and A minus ions. Now by applying law of mass action. What is law of mass action? You refer to chemical equilibrium chapter video please. By applying law of mass action, what I will have K, as this is the constant I am using for acid, I will use here Ka is equal to active mass of the products to the active mass of Ha. Right students? Now if I see this Ka, what I will call this as the dissociation constant of weak acid, or it is called as the dissociation constant of acid, or it is called acidity constant. Now students, if I say that this Ka value will be more, means what? When this value will be more, if this concentration is more, this concentration is more, or this concentration is less. When I say that this concentration will be more, I mean this concentration should be more. When I say this concentration is more, when will be this concentration more students? If this Ha will dissociate to a greater extent. And when this will dissociate to a greater extent, this concentration will be more, this concentration will be more, and this value will be high. So can I say if K value is high, the acid will be strong. Similarly, when I say that K value is low, when this K value will be low students, this K value will be low, when this will be more. When this will be more, if this remains as it is and it is not undergoing any dissociation, means the K value less, means the acid is weaker. So can I say that higher the value of Ka, stronger will be the acid. Means higher the value of dissociation constant of acid or acidity constant. So higher the value of dissociation constant or acidity constant, stronger is the acid. Let me revise this again student. When this K value will be more, this K value will be more if this concentration is more. And when this concentration will be more, when this concentration is more, means what? More and more Ha will dissociate, forming more and more H plus and A minus ions. So depending upon this K value, you can predict whether the acid is strong or weak. Now let us create the definition of acidity constant. How I can define acidity constant? This is the equilibrium constant, or I will say it is a constant which is obtained by applying law of mass action to the dissociation reaction of an acid. Which acid, student? Weak acid. Why we are considering weak acid? So that we can trace the rate of the reaction comfortably. So this is what is called as acidity constant or dissociation constant of an acid. So I am repeating, higher the value of dissociation constant, stronger is the acid. On the same basis, now let us go for the basicity constant or dissociation constant of a base. Now it will be easy for you to understand because concept will remain the same. So let us come to the dissociation constant of base. For that I am using the constant as Kb. This is called basicity constant, or it is also called as dissociation constant of a base. Consider a weak base. I will take BOH dissolved in water. Now how this will dissociate, student? BOH aqueous will give you B plus and OH minus ions. Now applying law of mass action, K, now it's a base, so I am using Kb is equal to active mass of B plus and active mass of OH minus ions upon BOH. Right, students? This is what is basicity constant or also called as dissociation constant of a base. Now listen this statement again. When this Kb will be high, when this Kb will be high, when this concentration will be more. And when this concentration will be more, when this concentration should increase. And when this concentration will increase, student, when more and more BOH will dissociate. When more and more BOH will dissociate, you will get more number of OH minus ions. When you get more number of OH minus ions, this concentration will increase, increasing the value of basicity constant. So again, higher the value of basicity constant, stronger will be the base. Very important. On the same basis, if I say when this value will be low, when this value will be low, means this concentration should be less. When this concentration less, means this will come out to be in a very less amount. And when this OH minus will be less, means this is a weak electrolyte. So depending upon the value of Kb, you can say which base is stronger and which base is weaker. So again, if I want to define basicity constant, how I can define basicity constant? Basicity constant of a base can be defined as the constant which is obtained by applying law of mass action to the dissociation reaction of a base. So this is how you can define the acidity constant and basicity constant. Students, it's very important for your MCQs to remember that for weak acid like acetic acid and weak base like ammonium hydroxide, when I say weak acid, it must be it's Kb and Ka I am talking about, and when I talk about ammonium hydroxide, it's Kb what I am talking about. Their values, they are fixed. That is 1.8 into 10 raised to minus 5. So always remember, whatever is the concentration, if their acidity constant or basicity constant for acetic acid and ammonium hydroxide, they are always fixed. So whenever you get an MCQ question, your answers must be nearly this. They can change this to 1.75, this range, but the range of power here, minus 5, will remain same. So this is all about the dissociation constants of acids and bases. Thank you, students.